All right, so we've covered some of the core calculated columns with DAX. Now it's time to talk measures. And the natural place to start is with these basic math and stats aggregator functions. So usual suspects here, you'll see your sum, average, max, min, and a new one called divide, which I'll talk about in just a second. But these, for the most part, speak for themselves. Very straightforward. The sum evaluates the sum of a column. Syntax-wise, all you have to do is point to a column name containing values. Similar story with average, just returns the arithmetic mean of all the numbers in a column. Same syntax. Now for max, obviously returns the largest value, but you don't have to just point to a column. You could also feed a max function a list of scalar or specific values, and max will return the largest within that list. Same goes for min, exact same syntax, just returns the smallest value. And then divide, it performs division, but it also includes this alternate result, which is kind of like your value if error, kind of baked right into the formula. So numerator, denominator, alternate result. So really no surprises here. Let's spend most of our time in Power BI practicing some of these hands-on. All right, so I'm back in my AdventureWorks report, and keep in mind you can add measures in a number of different places. I could add them here in the report view, in the calculations grouping. I can add them anywhere I can see the field list, either report view or data view. Really doesn't matter where you add them. I generally like to add them in the report view because since measures won't actually be visible in our tables, the best way to QA and explore the values that our measures produce is using visuals like the matrix visual here. So let's get in the habit of creating our measures here in the reporting canvas. And like I mentioned earlier, rather than using the modeling tab, which sometimes assigns your measures to tables that you didn't mean to, we're going to also get in the habit of actually right-clicking the table itself or field within the table itself to deliberately organize where these measures are going to live. So to kick it off, I'm going to use the basic sum first, and there are two different measures that I want to create. The first is the quantity returned, or the sum of the return quantity from my returns table. So just like we calculated the quantity sold here in our sales table, we're going to calculate quantity returned in our return table. So again, I'm going to right click the returns table, this time new measure instead of new column, and it basically just adds a placeholder right here in the formula bar that says measure equals. So this one will be named quantity returned, and it's going to be quite simple, just your basic sum. I'll start typing return. So there we go. AW returns return quantity. That's the numerical field that we would like to sum. And it's as simple as that. Close the parenthesis, press enter, and there you go. You'll notice that all it's done is create a new field assigned to my returns table with that measure. But the only way to see the result of that measure is to visualize it. Pull it into the values field of some sort of visualization, whether it's a matrix or a chart. So for instance, if I wanted to add a third column here in the matrix we've got, I can just grab quantity returned and pull it in as a third column of values here. And because we're breaking down the data by product key, which our returns table is connected to, then this is a valid view. Now let's do a very similar example, except this time let's add one to our sales table. Right click, new measure, and we've got this raw revenue field, these revenue values in that new column that we created using related in the last lecture. So basically I just want to sum those up. I'm going to call it total revenue equals the sum of that AW sales revenue column, and press enter. So as a reminder here, you might be wondering, isn't that kind of a redundant step? Is that really necessary? Because I could pull total revenue into this matrix view, right? Or I could pull the raw revenue values from my table into that view as well and get the same answer. So was that measure calculation just an extra unnecessary step? And again, it comes down to this idea of implicit versus explicit measures. And what I just showed you in the second example with those raw revenue values, That was an implicit measure which can't be used anywhere else. Whereas my total revenue measure now can plug into other sorts of DAX calculations, like profit, for instance. So you'll note that it's not formatted as currency here. You can access formatting tools here as well just by clicking the measure itself and then accessing those formatting tools here in the modeling tab, which you saw was also accessible through the data view. So instead of general, this revenue is going to be English United States currency. And there you have it. So we just used sum to create two new measures, two new numerical values that we can analyze in our model, quantity returned and total revenue. And now that we have quantity sold and quantity returned, those two pieces could serve as interesting components to another new value like return rate. So I think that's something that AdventureWorks might be interested in seeing, not only the raw volume of sales and returns for their different products and territories and categories, but the actual return rate as well. So are accessories returned more frequently than bicycles? Are there certain territories where return rates are unusually or concerningly high? By creating these new numerical values with measures, we're giving ourselves, or we're creating for ourselves, these tools that we can use to answer those types of analytical questions. So let's try creating that return rate column. And we can assign it to any table we want. I think it makes sense to either go in sales or returns because it's going to contain a component of both. We're going to be using the quantity sold measure in the sales table and the quantity returned measure in the returns table. Now, since this is more of a return specific measure, let's go ahead and assign it to the AW returns table. So right click that header, press new measure, and we're going to name this one return rate. And two ways to do this. You can either use the division operator or the divide function. Both are valid. Again, the divide function just gives you that optional third argument. Now, this is also a good point in time to remind you about the difference between columns and measures and the fact that measures can't reference naked column types or columns that don't have some sort of an aggregator assigned to them. So for sake of example, what if we tried to calculate return rate as just the order quantity column from the sales table divided by the return quantity column from the returns table? If I try to start typing, it's not even allowing me to access that column because Power BI knows that I need some other piece of information here. I need some sort of aggregation, whether I'm defining aggregation here in the function, like the sum of the return quantity or order quantity, which is valid, or a measure like quantity returned or quantity sold, which is built from an aggregation. So in this case, our return rate, we're going to define it in a pretty simple way, just the quantity returned, and I'm using the measure that we've already created divided by quantity sold. So we're just coming up with a simple ratio here. And this is what I'm talking about with measure trees. We're using individual measures as components nested within new measures like this one, return rate. So I could press enter, and that should work just fine. You can go ahead and pull return rate into this same matrix view as well. And if we want to format this, let's make it a percentage here. And it's going to default to 2 decimal points, which looks good. And again, this is the operator version of the function. We could also use the divide just to see what that looks like. Equals divide, and then numerator, comma, denominator, comma, alternate result. So my numerator, again, is quantity returned. My denominator is quantity sold. And then the alternate result, so in cases where we get an error, that's going to be a div 0, and it's going to happen in cases where I have no quantity sold values. In this case, that shouldn't be an issue because we won't see returns in cases where there were no products sold. But just to cover our bases, we could do something like no sales as our alternate result. So in some case that we happen to run into a div 0 error with this divide function, we would just assign that label of no sales instead of the error message itself. So that should be good. And when we press enter, produce the exact same values. There you go, it just refreshed, nothing's changed. So that looks good. And now let's simplify this view a little bit. I want to explore things just for a second. Let's pull order quantity out. Let's pull total revenue out. So now we're just looking at sales, returns, and the return rate. And instead of breaking this down by product key, which is really, really granular, let's remove that. And let's actually look at product categories at kind of a higher level. So category name in our rows instead. This is starting to give us some interesting insight already. This tells us that the product category that's returned least often are accessories, and most often are bikes. And then you can see clothing kind of falls somewhere in between at 2.16%. So already, just by using some pretty simple measures like sum and divide, we're able to take our analysis to an entirely new level. And to be honest, we are just getting started. Now, the last basic math and stats demo that I want to walk through is the average function. And so to use average, let's say we want to create a field to calculate the average retail price. Now, since retail price is an attribute of my products, I'm going to access that field within my product lookup. There it is, product price. I'm going to add a new measure right here within the table. You can see I can right click anywhere inside the table. It doesn't have to be the header. Choose new measure. And let's call this measure average AVG retail price. And super simple. We're just going to use the average function. And I'm going to type price to search for it. Product lookup, product price, close it off, and press enter. So it's created that new measure, that new field in my table for average retail price. And let's go ahead and pull that field into our matrix. Now, one thing you'll notice is that now we're seeing average retail prices even for categories or products that weren't even sold in the data set. And that's because even though they don't exist in the sales or the returns records, they do exist in our product tables because they're part of the product lookup. And because we do have retail prices associated with every product key, then we are still able to calculate the average even with no sales. So let's go ahead and format this one as a currency as well. There you go. And now one last little teaser that I want to show you, just one of the reasons why these visuals in Power BI are so cool, is that so far we've just been looking at individual row labels, in this case category name. But what you can do is some interesting things like pull in another field, let's say subcategory name, drag it in under category name. You'll see the view didn't change, but what we can do now is use these drill buttons to actually go to a different level in the data. So we've just drilled up from category name, down into subcategories, and we could stack or nest additional ones in here as well, like products, actual product name as a third level, and then drill even deeper. That's giving users the ability to kind of self-discover and explore the data and drill in and out at different levels. Or you could use this last button here to show your deeper levels within the same view, like so. So we're going to talk a lot more about exactly how these visuals work and some of the other incredibly useful tools available in this report pane, but more on that to come. So there you have it, creating measures using those basic math and stats functions.